In this module, we're going to do more than simply retrieve data from tables. We're going to turn that data into more usable information. We're going to do that through identifying the data types that we're using. We need to know the data types in order to properly create calculated columns and to write concatenated expressions. Concatenations, putting things together. We're going to use character, numeric, and date-time data types in expressions. We're going to use the cast function, which is the ANSI standard, and we're going to use the convert function, which offers more features and is used within T-SQL. And we're going to look at the null value. We will begin work with expressions. This is a form of operation involving numbers, character strings, dates, or times. It can also use values drawn from specific columns in a table. It can use constant or literal values, or a combination of both. We're going to use these to broaden or narrow the scope of the information that's retrieved. And we need to be aware of data types as we're doing this. The data type is going to impact the value that the expression returns. The ANSI standard defines 7 general categories of types of data: character, binary, numeric, and numeric is broken into exact and approximate, Boolean, date, time, and interval. These are all shown in your book. It's important that you pay attention to these. There's also a short synopsis of data types within the lecture. We'll look at the cast function. The cast function is an ANSI standard that helps us convert a data type from one type to another. In the demos, you're also going to see the convert function. And the convert function is used in T-SQL. It's similar to the cast function, however it adds another attribute, and you will see that demoed both in the lecture on cast and convert and also in the quick demo that I'll do of some of the problems that are presented in this module. When we're dealing with character string literals, character strings are enclosed in single quotes. If you look at the example here, we're going to select Vend Web Page, Vend Name from Vendors. Now if we want to put it together, Vend Web Page is the field, and a character string is the website for, and then the Vend Name. This will result in the web page, the text, and the vendor name. Numeric literals can consist of an optional sign and a number. They can include decimal place, the exponent symbol, an exponential number. We're going to be doing a lot of math in SQL, so it's important to learn how to use these. We're also going to be doing a lot of work with date and time literals. You'll see several examples of those within our demos. As you can see from the section on concatenations, the SQL standard supports the 2 vertical bars, but in Microsoft Access and in T-SQL, we're going to be using the AND or the plus operator. Access is normally the AND operator, and in T-SQL and also in Crystal Reports, you're going to be using the plus operator. So if we see the double bars in the textbook, we're going to replace that with a plus sign when we're writing in SQL Server Management Studio. There are a number of mathematical expressions. We're going to be working with some of the more common ones. In this chapter, we'll be looking at addition, subtraction, multiplication, and division. We're not going to be looking at any of the scientific features or the trig features in this chapter. Order of precedence is important. You need to understand that the math is going to be performed in a certain way. If you want to override the way that the math is done within the programming language, then you need to use parentheses. We can perform mathematical operations on dates and times. Your book goes through a description of how to handle date and time expressions. Time expressions are handled very similar to dates. You'll see some examples of using date expressions within our demos, and time can be done in a very similar manner. We're going to be using expressions in a select clause. The concatenation expression will allow us to create readability within our output. For example, if we want to produce a person's name for a mailing list, we can put the names together through a concatenation expression. We can also put a label or an identifier in front of a column value. That will better identify what that particular value actually means. We're also going to be able to name expressions. We're going to be doing it with the as keyword. An example, we're going to select DOB as date of birth. We're not going to put spaces in our aliases, and we're going to do that simply because it's easier for the database to deal with. We'll be doing work with mathematical expressions. The math expressions are probably the most versatile of the three types of expressions. We're going to be working with data expressions. They're done similar to math expressions, and we can use addition and subtraction. We'll also look at value expressions. A value expression is a value that is used by some component of an SQL statement. You're going to do a little bit of research on nulls. What we need to understand is that null is not 0. Null is the absence of a value. It represents an unknown value or missing information. The problem with a null is that any operation involving a null evaluates to a null, which means if we add a first name to a last name and we don't have a last name, we end up with a null value. And as we move forward, we're going to be looking at ways of dealing with null values within our data.